Good afternoon and welcome back to another new video. In this video, we have a new background. So you can see a new tree over there and there's some pictures over there as well as a new bookshelf. So I hope you guys all like it. So the main topic of today's video is an experimental technique called dynamic light scattering, or DLS for short. DLS, or dynamic light scattering, is an experimental method most commonly used in fields such as pharmacology and materials science to determine the particle size of a certain sample. Particle size, as you may know, is an important metric that can be used to determine many properties of a material. So for example, if you have a drug that is in powder form, you might want to know the size of the particle, to know how soluble it is, how efficient it is when it is absorbed, and many other properties that can be derived from particle size. So I will mention briefly here how DLS works. Please note that this is very simple terms and may not be complete. So imagine you have a water sample. So when light passes through that water sample, it behaves a certain way. So imagine you have additional solid objects within that water sample. So when light passes through, it will behave differently from as if the sample is clear, and the light will be scattered around because of the solid particles. And how that light scatters generate data from the DLS method. And from that data, particle size can be extrapolated, calculated using formulas that is automated by software. At the end, you will receive a graph detailing the composition, the size distribution of your sample. So now I will talk about the steps to operate the DLS machine. So if you are a standalone operator, this is the order of operations. First, you turn on the machine, power it up. Next, you turn on the controller software on the computer and you let that whole apparatus sit for about 15 minutes while you prepare your sample. So the next step is preparing your sample. You can either prepare your sample beforehand, although I do not recommend this. It is best to prepare your sample and then use it immediately because of reasons I will mention later. So when you prepare your sample, you mix it with water or any solution you want. The program may have an option for you to choose the type of solvent, but most often people use water because it doesn't matter if your sample is soluble or not. I think I have not done with all the types of materials, but I think it does not matter if your sample is a colloid or a suspension. So when you have prepared your sample, you will put it into what is known as a cuvette. So a cuvette, a standard cuvette, has walls of 1 centimeter, and there will be two types of surfaces. There will be a smooth glass surface and there will be a rough surface. So the important thing to remember, always remember here, is that you need to hold the cuvette on the smooth surface. You need to hold it on the rough surface, because the smooth surface is where the light will be passed through and it will enter the sample and then exit the sample to generate the data for you. So when you hold onto the smooth part, it will contaminate the glass and it will make your data look very wrong. And another thing to note is before you put it into the machine, maybe use a cotton pad to clean that smooth surface first so that it will give you more accurate results. So when you have put your sample into the cuvette, you need to put the cuvette inside the DLS machine. So inside the DLS machine, there will be an arrow indicator. So you will need to put your cuvette, the smooth part of your cuvette, where the arrow points. So if the arrow points like this, and then you will need to put the smooth surface here. The arrow represents the direction of light. So you want to put the smooth surface in the direction of the light. So this is the arrow, this is your cuvette, this is smooth, so light will pass through here and then pass through here and will generate the data for you. And finally, as promised, I will give you some tips to, have a good DLS result and accurate readings. So the first has to do with your sample. So as you know, many materials tend to aggregate or clump up together in large masses, and this will cause the DLS results to look very bad. It will say that your sample is over 6,000 nanometers large. That is the limit for my machine. So if you don't treat your sample, it will aggregate usually, and the results will be wrong. So what I recommend is put your sample in a supersonic bath where the force, the shaking will force the particles apart and distribute it very evenly. Right? Or you have a stirrer, you can use that as well. So the keynote here is to treat the sample however, so that the particles do not clump up, and that will give you a better reading. So the second thing about sample preparation is that you need, for the DLS, you need a certain concentration range for it to work. So the DLS only works for samples that the concentration of the sample needs to be just right. So whenever you put the cuvette into the machine will tell you that either it is too sparsely concentrated, it is too densely concentrated, or is it correctly concentrated. My tip here is to mix a very low concentration solution first, right? Put it into the machine and see where your concentration is on the bar that they give you. So if the concentration is too low, you can add more of your sample in, just a little bit of your sample in, to increase the concentration, stir it, and then put it in the DLS machine again. Repeat this until you get the correct concentration that the machine requires you. That is the second tip on sample preparation. And the third tip, as I have said, use your samples immediately, right? So if you put your samples, in a refrigerator, put it outside too long, and then you use it for DLS later, many, they are busy. They forget the samples, they don't want to mix it again. But this actually gives very, different results from when you are, let's say, doing it immediately after preparing your sample, because over time, things in the lab, like such as dust, external force, maybe light, things like that. Maybe your sample degrades over time when exposed to oxygen. You cannot guarantee all of those. So it is best that when you prepare a sample, you measure it immediately. Right, and another thing about, the DLS machine is that this is my personal experience. I don't know if, the machinery in your lab is different, but for me, the DLS is kind of, unreliable in a way. So last week, I measured a sample, right? So I made sure that the sample is in the right concentration. But whenever I try to measure it, first the concentration would be right, and then the measurement would proceed to about like 20%, and it would drop down. And it will say that my concentration is too low. I will have to reboot the machine and rerun the experiment again. So this took a few tries. So I do not know what the cause of this is. And I cannot explain why that the concentration keeps changing according to the machine, not according to me. The concentration was the same across all the samples, all the tries, but the machine keeps saying that, one time I have it correct, one time I don't have it correct, one time, alternating, things like that. That is very weird. So the final tip is to stay patient, because sometimes, the machinery in your lab can be somewhat outdated. The sensors are not that good, and definitely reserve a few hours just to sit at the DLS machine and try to get the best results possible, so you don't have to do the entire process again. So that is all I have for today. You guys have a nice day. I will see you soon in my next video. Thank you for watching.